My name is Steve Sparks. I'm a Professor of Geology at the University of Bristol, and I'm involved in the BHP project principally because I'm a volcanologist. I work on active volcanoes. Now, the link between active volcanoes and the formation of porphyry copper deposits is that very likely the majority of porphyry copper deposits are the eroded roots of active volcanoes. So by studying and understanding what happens in young volcanoes, we can use that understanding to come back and look at what happened to form porphyry copper deposits. I've worked extensively in the Andes on some of the active volcanoes there, and that is very relevant to the BHP project because many of the world's most important porphyry copper deposits are in fact in South America, in particular in places like Chile and Peru.
My name's Frances Cooper and I'm the BHP Billiton lecturer here at Bristol. Well, the aim of this project is to understand the formation of porphyry copper deposits in different tectonic settings, and the one that we're really focusing on is in northern Chile, which is in a really exciting tectonic location because we're right on the edge of the Andean Altiplano, which is the second largest plateau in the world after Tibet. And I find that it's a very interesting question of why it is that we find these big porphyry copper deposits in this particular location just on the very edge of this large plateau. And my previous experience working in tectonic settings around the world, including the Himalayas and the Basin and Range province in the USA, have given me background knowledge of such settings, and I can use that information and that background knowledge to apply it to this new world of porphyry copper formation.
The main issue for understanding porphyry copper deposits is how you get huge amounts of copper deposited in a very small area, because in most parts of the world, in most rocks, the amount of copper in them is so small that you couldn't possibly mine it and extract copper. So what you need is a process which concentrates all that copper in a very small area. Now, in an active volcano, we have some idea about what happens, because when you get a volcanic eruption, the crust of the earth is broken and lots of fluids and molten rock or magmas escape through a very narrow area between the deeper parts of the earth and the surface. And we think that the processes which lead to volcanic eruptions also lead to the conditions which you need to form porphyry copper deposits.
My role on the project is twofold. On the one hand, I lead the tectonic and structural geology aspects of understanding porphyry copper formation, particularly focused on the northern Chilean Andes. On the other hand, I run a new economic geology course here at Bristol. Bristol didn't have much of an economic geology background before, and so that's a new thing that we've brought to the department. One of the really great perks about working for the BHP Billiton Project is we have access to an enormous collection of ore deposits from around the world. We've got an example of copper sulfides in this very dense dark sample here, compared with a copper oxide, which is the bright green one that you're probably more used to seeing. So the students have an opportunity to look at all these different types of deposits that have come directly from BHP Billiton operations around the world. And in the drawer above, for example, we have some iron ore deposits. These are from Australia, and you can see some beautiful hematite, very shiny, a classic bit of banded iron formation. So the students here at Bristol, this is a third-year course, and they have access to some amazing rock samples.
Now, when we look at eroded volcanoes around the world, many of them don't form porphyry copper deposits. So we've got to think of something going on back in geological time, which is a bit unusual to form a porphyry copper deposit. And what we think is that in volcanoes, particularly volcanoes where the Earth's crust is being compressed or squashed, the magmas and the fluids which are going to form the copper deposits are trapped in there, and they only escape very occasionally. And when they do escape, very large volumes of fluids from deep in the earth and magmas come up through a very narrow place, probably cause a volcanic eruption, and simultaneously the copper is brought up and deposited in the roots of the volcano, and that's how we're thinking that they might form. So one of the main ideas behind the project in collaboration with BHP is this idea that if we apply our understanding of very young volcanoes to old eroded volcanoes, we can better understand where the porphyry coppers might form, how they form, and how to find future copper deposits, and also develop the mines associated with those copper deposits.